Welcome to another science exploration video. Today we're going to explore about how does USB fan works and its energy conversion. It might look like just a simple, everyday gadget sitting on your desk. But trust me, there's some truly fascinating science happening inside to keep you cool. Let's get right into it.
Section 1. Powering up the motor.
Think about where you plug that fan in. It could be your laptop, a portable power bank, a wall charger, maybe even a little USB adapter. Well, no matter where it's plugged in, that USB port supplies a very specific amount of electrical energy. And that magic number? Just 5 volts. Yeah, just 5. Most of these USB fans run entirely on this super small amount of electricity, which travels right up that little cable.
Moving on to our next part, inside the tiny motor.
So where does that 5 volts of electricity go? It flows right into a tiny electric motor hidden directly in the center of the fan. Now, this little machine is made up of copper wire coils, some magnets, and a rotating part that we call a rotor. And the way these 3 parts work together is absolutely amazing.
Which brings us to magnets making the spin. Here's where the magic really happens. As the electricity from the USB port flows through those copper coils we just talked about, the coils actually become magnetic. Literally, they turn into electromagnets. And once they're magnetized, they start interacting with the permanent magnets that are already sitting inside the motor. This creates a constant back and forth cycle of pushing and pulling magnetic forces. And you guessed it, it's these exact pushing and pulling forces that make the motor, and the rotor inside it, spin continuously.
Next up, creating the cool breeze.
Okay, so the motor is spinning, the motor shaft is connected directly to the fan blades. So when the motor spins, the blades spin right along with it. But have you ever stopped and wondered why those blades are specially shaped with a curve? Why aren't they just, completely flat? Well, acting just like little scoops, these curved fan blades are specially designed to do 2 things at exactly the same time. First, they eagerly pull air from behind the fan. Then, they immediately push all that gathered air forward. This continuous pulling and pushing of the air is exactly what creates that lovely, cool breeze we feel on our faces. Pretty clever, right?
Now, you've probably noticed that these little USB fans don't exactly spin as fast as a giant ceiling fan, and there's a really good reason for that. Because USB ports provide a strictly limited amount of power, these fans have to use smaller motors and consume very low electricity. This means they naturally spin a bit slower. But hey, that's actually a great thing. It keeps them wonderfully quiet and way safer for us to use right there on our desks.
Let's look at the big picture, the energy conversion journey.
In science, there's a big rule. Energy doesn't just vanish, it transforms from one type to another. We start our journey with electrical energy coming from the USB port. That electrical energy travels up to the motor, where it seamlessly converts into mechanical energy, which is the actual physical rotation of the motor itself. Finally, those spinning blades turn that mechanical energy into kinetic energy, and that kinetic energy is the moving air that cools us down. It's like a perfectly choreographed dance.
And finally, our summary.
So, to summarize our entire explainer today, a USB fan works when electricity from the USB port powers a very small motor. That motor then spins the curved fan blades, which expertly pull and push air forward. It's an incredible little journey from raw electricity to a relaxing, cool breeze.
So the next time you switch on your little desk fan, you'll know exactly the kind of science happening right in front of you. If you find the video informative, please like the video. Thanks.